Hello, you're welcome back to our discussion on quadratic equations. And today we are going to look at how to construct the graphs of quadratic equations using the tables we've constructed. In the previous lesson, we talked about how to construct the table of values for quadratic equations. So today we are going to look at how we can use the table we've constructed to design our graph. Now let us assume that we have this table. We've constructed this table where we have these values x and y, and our x is -3, -2, -1, 0, 1, 2, and y is 3, -1, -3, -3, then 1, 1, 3. Okay, so we have this. Okay, these are the values for our x and our y. Now, how do we plot this graph? To plot this graph, the first thing that they will always give us is the scale we are going to use. If they don't give you a scale, you choose a scale that will make the graph not to be too small. If your scale is too small, your graph will be very, very tiny. And if your scale is too big, your graph sheet may not contain your values. So you look at your graph and look at the values you have, and then you know the kind of scale you are going to choose. What do I mean by scale? Now, if this is how our graph book looks like, the scale means the space given for each of the values. The space given for each of the values. Now, assuming for this table we have, let's create the x and y axis. X and y axis. Now let us assume that each of these tiny lines is 1 cm. That is this one 1 cm, this one 1 cm, this one 1 cm, each of the tiny lines 1 cm. Now they may tell us that we should choose 2 cm to represent 1 unit. If we are told this, it means that we go back to our table. Whatever we have in our table, we count, as we are counting for x axis. This place is x axis and this one is y axis. The one lying horizontal is the x axis, while the one going up is the vertical or y axis. You can change the name of this axis. This is just the general name. If you are plotting a graph of, let me say, centigrade against meters, that means that you are not going to number this thing x and y. You are going to number it with the units of what you are plotting. If you are plotting centigrade against meters, that means that this one will be centigrade and this one will be meters. So, but if you don't know the unit of what you are plotting, or if you don't have a unit for it, you can label it x and y. If you know the unit, you must put the units for it. So, but this one is just the general name for the two axes. Now, this place of the graph is positive for y. This side is positive while this side is negative for x-axis. Now coming to this side, the right hand side, this place is positive for x and also positive for y. Now y coming down to the graph, this place is positive to x and this place is for negative for y. This place is negative for y. Now this place is negative for x and negative for y. That means that your positive values for y will be plotted here. Your negative values for y will be plotted here. Positive values for x will be plotted here, and negative values for x will be plotted here. Now with that, let's plot what we have in the table. In the table we have -3 and 3, x -3 and y 3. Now let's number our values. They say we should choose 2 cm to represent 1 unit. That is, this is 1 2 1 1 2 2 1 2 3 1 2 minus 1 1 2 minus 2 1 2 minus 3 1 2 1 1 2 2 1 2 3 1 2 minus 1 1 2 minus 2 1 2 minus 3. The number we are going to stop at depends on what we have in our table. For y, the highest value is +3, so we have +3. While the smallest number is -3, so we have -3, that is -3. For x, the highest value is +2. We have +2. We can just decide to put 1 to make it uniform with y-axis. If we leave it at 2, we are not going to have any problem with our plots. While the smallest number is -3. Of course, it makes sense that if you have -3 here, we also compare this one to 3, so that you have minus the same value for minus and then positive. Now we plot -3 and +3. -3 in the x-axis and +3 in the y-axis. This is +3 and this is -3. So we trace the lines for each of them where they join, that is the junction. We asterisk it. We go to the second number, -2 and -1, -2x and -1y, 1 2. Okay, so we get to this side, we asterisk it, then we go back to the table, -1 and -3, -1x and -3y, -1 and -3. We asterisk it, then we go back, 0 and -3. This is 0 points, the origin, the junction. So if we want to trace the 0 for x, it's going to lie on the line of y. So that is going to be here. Exactly at minus 3y. Now 1 and 1, 1x and 1y, so we have and for we have 2x and 3y, 2x and then 3y. Now we have plotted the junctions. Now we draw our curve to join all the points we have joined together, or to touch all the junctions. Okay, now for this graph, for us to find the root of this quadratic equation, the root is where the curve touches the x-axis. So we come to this side and check where it touches the x-axis, this place. We mark it, and where it touches the x-axis, this side, we mark it, and that becomes the values for the root of the quadratic equation. Where it touches the x-axis at each side, normally quadratic equation has two roots. So the quadratic graph will normally touch the graph at 2 points along the x-axis. Those places are the roots of the quadratic equation. So we just come here and trace the value where it touches the x-axis, and that becomes our roots for the quadratic equation.